Hey, what is up guys, Omogonix here and welcome back to a brand new video here on the channel. So this is part 11 of my tutorial series where I teach you guys how to make a first person horror game in Godot. So in this part today, what I'm going to be doing is I'm going to be teaching you guys how to make the enemy AI. So I know that a lot of you guys have actually been waiting for me to do this. I've been getting, comments from you guys saying, oh, when are you going to do the enemy AI? And the answer is today. So here in part 11, we're going to be making the enemy AI. So first off, before we do make the enemy AI, it is going to need a navigation mesh in order to walk around on. So what I'm going to do is I'm going to go into my house scene here. I'm going to select the parent node of my house, and then I'm going to go add a child node. And then what I'm going to do is I'm then going to search up a nav. So you want to search up a nav when creating a new node. And then what you want to add is a new navigation region 3D. So once you do select it, you then just go create and boom. So now we have a navigation region 3D in our scene. So the navigation region 3D is basically what's going to be used in order for our AI to navigate. So once you do add your navigation region 3D into the scene, just select it. And then where it says navigation mesh empty, you then just want to click here and then go new navigation mesh. And boom, so now we have a new navigation mesh created. And now if we click bake navigation mesh at the moment, nothing is going to happen. And that's because in order for things to be baked into our navigation mesh, they need to be a child of the navigation region itself. So what you want to do is you want to select any object in your scene that you want to be part of your navigation mesh. So whether it's something that you want your AI to avoid, like an obstacle or a floor or a wall or something like that, right? Be sure to add that as a child node of the navigation region 3D. So what I'm going to do here, for example, is I'm going to select my furniture, I'm going to select the stairs, I'm going to select the house meshes themselves. So there we go. So I'm selecting the house walls and floors, the stairs, the furniture, and also the bins as well. And then what I'm going to do is I'm now going to make these a child node of my navigation region 3D. And then once you make the nodes that you want to be part of your navigation region 3D, children of the navigation region 3D, what we can do now is we can now go bake navigation mesh and boom. Now as you can see, we have a nav mesh baked. So since I didn't make my doors children of the navigation region 3D, as you can see the navigation mesh goes straight through the doors, and I do want that after all since I want the AI to be able to enter other rooms. And so obviously I don't want the doors to be able to stop the AI from entering the other rooms, so yeah. Now when you do create your navigation region 3D, there are a couple settings you can play around with on it. And I don't really mess around with the settings too much on the navigation mesh, because, well, I find that the settings by default are already good enough. But one thing which I like to do is I like to go into the cells section here, and sometimes I like to change the cell height to something lower, like 0.05. Then if we go bake navigation mesh again, as you can see, the navigation mesh is now much more closer to the ground, and this is usually how I prefer it to be. You can also change things like the cell size. If we were to change this to 0.1, for example, as you can see, basically it just changes up the mesh of the navigation region. I usually like to have that set to 0.25, which is usually the default. But again, it all depends on what you're doing. So yeah, when it comes to the sampling, I don't usually play around with this. I usually just leave that as default. Geometry, I usually leave that as default. But yeah, usually all I do really mess around with is the cell height. And also we do have other settings here like the agents, so we can actually set settings for our navigation agents. So if I was to set the radius to 1, for example, as you can see, that actually gives us less room for our AI to move around in, since basically what we're telling the navigation mesh is our AI agent is going to be wider, so therefore that basically gives them less room to move around in. However, if their radius is only something like 0.25, for example, then as you can see, our AI then has a lot more room to move around, and they can get much more closer to objects. So basically, the higher the radius, the more further away from objects the navigation region is. But then the lower the radius, the closer to objects the navigation region is. We can also change things like the max climb, which sometimes I do mess around with depending on the game. So what the max climb does is this basically determines like how high the AI can walk up. So if I was to like set this to 5 meters, for example, as you can see, the navigation mesh now goes up on all these objects here. So it goes over the TV, so the AI would be able to walk on the TV, and the crates, and the couch, and all that sort of stuff. Now obviously we don't want that. What I do want, however, is I want the AI to be able to walk up the stairs. So overall, there's a bunch of settings to mess around with here when it comes to the navigation region. Feel free to play around with what you want to. And if you do want to learn more about certain properties as well, of course, you can just hover over them. And as you can see, Godot will actually provide you an explanation of what that property does. So yeah. So for now I am going to set the max climb back to its default value. I might play around with that later on though for the stairs. Alrighty, so now that we have our nav mesh baked in, there will be some more stuff we're going to be doing with the navigation later on, but of course we're just going to leave it for now. What we're going to be doing now, however, is we are actually going to be working on the enemy AI itself. So let's get started. So what I'm going to do is I'm going to create a new scene, a new 3D scene of course, and what I'm going to do is I'm going to make the parent node here a different type of node. So I'm going to right click, go change type. And now I'm going to set this to character body 3D. So sort of like with a player, this will be a character body 3D. And what I'm going to do is I'm going to call this just enemy for now. And then we will add a mesh in order to represent this enemy. So for now I'm going to be doing a capsule shape. However, I will be making an actual model for the enemy soon. I don't know if it's going to be in this part, but I will be doing an actual enemy model eventually with animations and stuff like that too. Right now I'm just going to be working on the functionality of the AI itself. So now of course you want to add a collision shape to your AI. I'm just going to be adding a capsule shape for now, which will hopefully work alright. And then lastly, for now we're going to be adding in a navigation agent 3D. So make sure you get that, and boom, create, there we go. Alright, so we have our nodes that we need for now. If we do need to add anything else, we'll add them later on. But for now, let's just select our enemy here, so the parent enemy node. And where it says script empty, we're going to create a new script now. So I'm going to save this into my scripts folder, general scripts, there we go. And, oh wait, first off I am going to be removing the basic movement template, since we won't be needing this at all for the enemy AI, so I'm just going to set it to node default, and there we go. Boom. Alright, so let's get started. I'm going to start off by just getting rid of the starter stuff, and we're going to be doing @export var, so we're going to be doing an exportable variable, and this will be patrol underscore destinations. So basically what this is going to be is this is going to be random destinations that the AI will be able to go to. So basically the patrol destinations is just going to be an array of random nodes which will determine where the AI will be able to walk to. So the AI will be randomly walking around the house basically searching for the player. So this is going to be an array of node 3Ds, as I said. And what an array is it's basically like a list, so you can add, you know, as many elements as you want to it. If you've been watching the other parts, you would already know that. And next we're going to be doing a variable for the player, so just var player. And also if you want to, we can actually set this variable for the player @onReady. So we can do @onReady var, and then we can do equals get underscore tree, dot current underscore scene, dot get underscore node, or dot get underscore node player, and that allows us to get our player just like that. Also I am going to save this scene for now, save it into my scenery folder, there we go. Now just in case, I will be adding a variable for the AI's speed as well. So by default I think I'll set this to 3 for now. And then we're also going to need a random number generator, so @onReady var rng equals random number generator dot new. So this will be used to randomly pick our AI's next destination. So once our AI reaches a destination, it will then randomly pick a destination from the patrol destinations using the random number generator. And then lastly, for now, we're going to be creating a variable for the destination itself. And there we go. Alrighty, so first off, let's actually create a function in order to pick a destination for our AI. So I'm going to go func pick destination, and then the two dots, and then indent. And so what we're going to do here is we're going to do destination equals, and then we'll do patrol destinations, and then you want to do brackets, and then inside of those brackets we're going to write rng.randy_range, so we're going to be picking between a range of integers, and those integers will be 0 and patrol destinations dot size -1. So basically what we're doing is we are basically picking a random patrol destination. And the reason as to why we do -1 here is because the size of an array is always going to be 1 above what the actual size is, so we just -1, and then that gives us the actual size of the array. So now, I just remembered as well, we will need a variable for chasing, but we're not going to be making use of it for now, but we will be making use of it later on. So what we're going to do here is in our ready function, so we're going to create a ready function, go func_ready, and then what we can do here is we can then write pick_destination. So basically at the start of the scene, our AI's destination is going to be picked. Also, we're going to need another function as well, and I'm going to call this func update target location. So basically what this is going to do is this is basically going to be what makes our AI move. So basically what the update target location function is going to be for is it's going to be used to, well, update the target location, obviously, as you can see. Pretty self-explanatory. And obviously the target refers to our destination, so whether that be the player or one of the random patrol destinations. So what you want to do here is you want to grab your navigation agent 3D. So we're going to go $navigation agent 3D, and then we want to do target_position equals to target_location. And there we go. Alrighty, now let's do a process function. So underneath my ready function, I'm going to go func_process, and there we go. So what we're going to do here is we're going to do if destination is not equal to null. The reason as to why we're doing this is because, we just want to make sure that the destination isn't null, so then there's no errors. We're going to do var look dir, and dir is short for direction, so basically we're going to be getting the AI's look direction. So to do this, we're going to be doing var look dir equals, and then we're going to be doing lerp_angle. And the reason as to why we're doing lerp_angle is because we're going to be smoothing the AI's rotation, because in Godot, AIs, when they're moving around, they don't rotate by default. We have to do it ourselves. So basically what we're doing is we're basically setting the AI's look direction. And then we're going to do deg_to_rad. So basically we're converting from degrees to radians. And we want to do global_rotation _degrees.y. And then next up, we're then going to be doing a comma, and then we're going to be doing a tan2, and then we want to do the parentheses again, and then we're going to do negative velocity.x, and then comma, negative velocity.z. So if you've never seen a tan2 before, basically this is what's used to help us get our AI's look direction by utilizing the velocity values here. And then we're going to do a comma again, and basically what we're going to be doing here is we're going to be adding in a weight. So basically what the weight is this will determine how fast the AI is going to rotate, basically. So the lower the weight value, the more smoother the rotation is going to appear, but the higher the weight value, the more abrupt it's going to be, so it's going to be a lot more faster. So with this weight value here, I'm going to be trying maybe 0.5 for now, I guess. We could see how that goes, but yeah. And then anyways, what we're going to be doing now is we're then going to be doing global_rotation_degrees.y, or degrees.y equals to. And now instead of converting from degrees to radians, we're going to be converting from radians to degrees. So we're going to be doing rad to deg. And then we want to do look_direction. And boom. Another thing which you want to do as well, of course, is we want to go down a line, and then we want to do update target location. And then for the target location here, we can then just enter in destination dot global underscore transform dot origin. The reason as to why I added in the target location variable into this function itself is just in case I wanted to switch between the player and the destination. But you know, I don't even know if it's really 100% needed to even have this here. So if you want to, you can just remove target location from this portion of the script. Because what we can do instead here, because we can just set the player as a destination at some point if we ever want the AI to chase the player. So instead of doing target location, we could just do destination.global underscore transform.origin directly into the update target location function. So yeah. Alright, I'm going to be doing a physics function now. So I'm going to do func underscore physics process. So what we're going to be doing here is we're going to be doing if not is on floor. So basically what we're checking for here is if our AI isn't on the floor, then what will happen is we'll do velocity equals, velocity plus equals get underscore gravity times delta. So basically what we're doing here is if our AI isn't on the floor, then our AI will fall downwards. And get gravity basically gets the gravity value of our project. So now we're going to do if destination not equal to null again, just to make sure that, you know, this stuff only happens if the destination isn't null. Var current underscore location equals global underscore transform to origin. So basically the current location is equal to ourselves. And then we do var next underscore location. And this will equal to navigation agent 3D dot get next path position. So basically we're getting the next path position of our AI. So then we do var new underscore velocity equals in parentheses accidentally just put a 9 up there. Sorry about that. So we're going to do in parentheses next underscore location minus current underscore location dot normalized times speed. So basically this is setting the velocity for our AI. And then we do navigation agent 3D dot set underscore velocity. And this will equal to new velocity. And there we go. So the reason as to why we do this calculation here for the new velocity is so then our AI's velocity is the correct speed it needs to be when going from the current location to the next location. So basically it just keeps the speed, you know, more favorable, if that makes sense. Alright, so that's all we're going to be doing for now when it comes to our AI script itself. Of course, there is some other stuff we have to do, but for now, for the actual AI script itself, we're just going to be leaving this for now. Let's now move on to another new thing that we need to do, and that is the actual destinations that our AI needs to go to. So what we're going to do here is we're going to go create a new node, so a new 3D scene here, and we're going to call this destination. And we're also going to have an area 3D as well, which will detect our AI, and we're going to give it a collision shape 3D. I'm going to make it a box shape, and there we go. Alright, let me just save this into my scenery folder. Alrighty. So what I'm going to do is I'm going to create a new script for this destination. So new script, going to save it into my scripts folder. Open and create. Alright, so before we do continue on with the destination, there is one little important thing which I forgot to do with the enemy AI script. So with that navigation agent 3D.setVelocity line, remove that, and instead underneath the new velocity line you want to do velocity equals velocity.move toward, and then you want to do new underscore velocity and then a weight of something maybe like 0.5 or 2.5 or whatever you find works best for you. And then underneath that you then want to do move and slide, and basically that is what actually makes our AI move, or our character body 3D move to be more exact. So yeah. Alrighty, so let's get back to the destination for now. So here we have our destination. Now what we're going to do here in our new script we created is we're going to create a new function. So we're going to get rid of this stuff here. We're going to create a new function called enter underscore trigger. And then we're going to do body here. So what body is this is going to be whatever body collides with this trigger, so whether it's the player or something else. But this trigger isn't going to be for the player, this trigger is actually going to be for the AI. So what we're going to do here is we're going to go if body.name equal to enemy, or whatever you have called your AI. If you've called your AI something else other than enemy, then you just put in that name here instead of enemy. So we're doing if body.name equals to enemy and body.destination equals to self. So basically what we're checking here is if this is the body's current destination. So since our enemy AI has a destination variable, we can check that. So if the body is named enemy and its destination is equal to this current destination, then what will happen is we will then make it so then the body picks a new destination. So we're going to go pick destination, I think is what the function's called. If you need a reminder of what your pick destination function's called on your script, you can just check. So yeah, for me it's called func pick destination, and what that does is it picks the destination of where the AI goes to next. So yeah. So now what we're going to do is with your Area 3D, you want to select your Area 3D trigger, go to the Node tab, and then body entered, and then we just want to connect up the enter trigger function, and boom, there we go. If the enemy's destination is currently equal to the destination it collides with, then that means it will pick a new destination. So what I'm going to do now is I'm actually going to go into my level scene, and I'm going to add in the enemy AI as a test here. So we're going to go enemy.tscn, and we're just going to drag it over here. So what I'm going to do now that we have our enemy AI here is we are now going to add in some destinations. We're only going to add in a few on this top floor as an example, and then I will add more later on as we do continue to develop up the AI. So we're going to go instantiate child scene, destination, and boom, there we go. So now I am going to just place a few around here for the enemy to alternate between. Alrighty, so I've got 5 different destinations here I'm going to be using as an example for now. I've just added 5 so then there is enough variation for the enemy to choose between. Alrighty, so with your enemy, what you want to do is you want to go into its patrol destinations array here, and then we're going to add some new elements, so just add as many positions as you want to. For now I'm only going to be doing 5 as an example to test this AI out. So I'm just going to drag those all into here. Alrighty, so now our AI's destinations should be ready. But for now what I'm going to do is I'm just going to turn up the radius of the agent, since I found that this can actually be a bit of a help. And we're going to create a new variable in our pick destination function itself. So this will be called, we'll just call this don't choose. This will be an integer value. And basically what this will be telling our pick destination function is, hey, do not choose this number. In fact, I think I'm going to make it equal to null for now, just so then we don't get any errors show up in our script. Because with the pick destination function up here, in the ready function, we don't actually need to put in any number here, so yeah. But anyways, we're going to do so we're going to do destination equals to a random patrol destination. However, if destination equal to patrol destinations and then brackets and then don't choose. So basically if the destination equals to the patrol destination that was just chosen before, then what will happen is if don't choose is less than 1, then destination will equal to patrol destinations don't underscore choose plus 1. So the reason as to why we're checking if don't choose is less than 1 is because obviously arrays, they have a range between 0 and whatever your max number is, and obviously we don't want it going under 0 because then that would put the array out of range, so yeah. So if don't choose is less than 1, then we're going to plus on to the actual patrol destination. However, if don't choose is equal to patrol destinations dot size minus 1, what will happen instead of plussing on to don't choose is we will minus. So yeah, and then basically what this is going to do is this is going to make sure that the destination, every single time we choose it, is going to always be different. So it's never going to be the same destination anytime at all. So what I'm going to do here as well in the enemy script is I'm going to create a new variable. We're going to call this destination value. And this is going to be for the destination script. So destination value, what this is going to equal to. So basically what I'm going to do here is I'm going to do something a little bit different with how we pick the destination. We're going to call this var num. And then we're just going to copy this bit here, this RNG bit here, move it over here, and then instead of destination equaling to patrol destinations and then the RNG value, we're then just going to do num, because num is basically going to equal to this. And the reason as to why we're doing this as well is so then we can go destination underscore value equals to num. And there we go. And so what we can do now in the destination script is with our pick destination function here, we can then do body.destination value as a way to tell our pick destination function to not choose the body's current destination value again. Oh, wait a second, another thing as well, we need to check if destination not equal to null. There we go. That's another thing which I forgot that we need to do. Oh, and also we need to make sure that don't choose isn't equal to null either. So we need to do don't choose not equal to null. And there we go. Also, another thing which I forgot to do as well, because one thing which I just realized is that this bit of code here isn't always going to work, because we're only checking if don't choose is less than 1 or if it's equal to the size of the patrol's destination. So with this, I'm actually going to do if don't choose less than equal to patrol destination dot size, and also don't underscore choose over 0. So that's another thing we're going to need to check, and boom. So now that should actually work properly now. I just realized that just before. Alrighty, so here we have our AI walking around. I am going to watch him for a bit just to make sure that, you know, everything does go according to plan. So right now it looks like everything is actually working quite well. Quite according to plan, I would say. So yeah, so far there's been no AI stopping. He's just been consistently choosing a new destination. So it looks like our plan worked. Now the AI is no longer choosing the same destination again. Alrighty guys, so what I'm going to do now is I'm actually going to add some more random positions around the house for the AI to go to. Now I won't be doing the downstairs yet since, well, as you can see, we don't really have any nav mesh going from the stairs that connects to the bottom and upstairs here. But don't worry, we'll be working on that. But for now, what I'm going to do is I'm just going to add some more random positions around for the AI to walk to. Alrighty, so I've placed some more random destinations around. Now what I'm going to do is I'm going to select my AI, and now I'm going to add them random destinations here into this array. So I have 12 destinations now. So now let's just go drag these in. Something else which I want to do as well for the AI is whenever they reach a destination, I want to have it so then they wait for a random amount of seconds and then they pick a new destination. One thing which I do actually also need to do is I'm going to add a mesh to the front of the AI. And the reason as to why is because I want to make sure that the AI's rotation is going right, and at the moment it's sort of hard to tell which way the enemy AI is facing, so that's why I'm having this cube here, just as a way for us to tell which way the AI is facing. Alrighty, so here I am in the destination script. So what I'm going to do here is I'm going to create a onReady var RNG, so we're creating a random number generator. Random number generator.new, there we go. So now what we're going to do here is after our enemy enters the trigger, we'll go await get underscore tree dot create underscore timer, and then we're going to do RNG dot, oh wait, I did R dot G, RNG dot randf underscore range, so we're going to be picking between a random range of floats. So we're going to pick between 1, so 1.0, and it depends on how long you want your enemy AI to be able to wait until, like the max time. So the minimum time for me will be 1 second, meaning the enemy AI can wait for 1 second, or they can wait for up to maybe, we could do like 10 seconds maybe as the maximum. Alrighty, so after setting a random range of floats, so basically what will happen here is we're going to be choosing between 1.0 and 10.0. The lowest value, 1.0, is the least amount of time the AI can wait in a position for, and 10.0 is the maximum amount of time the AI can potentially wait in a position for. So to make sure that this timer happens only when the game isn't paused, we want to do false for processed always, and then we do .timeout here. And there we go. So now, that should make the enemy actually wait before picking a position. Alright, so now what I'm going to do is I'm going to allow the AI to open and close doors. So I'm going to go into the door scene here, and I'm going to go add child node area 3D. So basically we're just creating a new trigger, and this will be a trigger for the AI as well. I'm just going to call this AI trigger, just so then we know. And then we're going to go add a child node to this, and it will be a collision shape 3D. I'm just going to do a box shape. And so for this collision shape, I recommend scaling it out to a point in which you want the door to be opened for the AI. So if you were to have the trigger be this length, for example, that means that the AI would be able to open up the door from this distance away. So just scale your trigger to whatever sort of size you want the AI to be able to open the door from. Alright, so this is what I'm going to be doing for mine. This is going to be my trigger. You guys can do something similar if you like. Alrighty, so what I'm going to do is I'm going to create a new function just for the AI itself. So I'm going to call this func AI toggle door. And it will have a body variable in it, of course. So I'm going to go if body.name equal to enemy. In fact, let me just change this func AI toggle door name to enable door, because we're going to be having a separate function for both entering and exiting. So if body.name equal to enemy, opened will equal to true. So this is if the player actually enters the trigger. So opened will equal to true. And then if the door's current animation isn't equal to open, then we will actually play the open door animation. Oh, and also we need to check that the door isn't locked as well. Of course. Alright, so now we're just going to copy this function, and this will be for the trigger, for exiting the trigger. So we'll just call this AI disable door, opened equal to false. Oh, also I just realized as well, it'd probably be better to have this up here, because otherwise I just realized that that would then actually create some issues if we didn't. So yeah, that should instead be like this. Hold on. Yeah, this makes a lot more sense now. There we go. And then we'll do play backwards for, shutting the door. And yeah. So there we go. Alrighty, so once you get them two functions done, now what you want to do is you want to select your AI trigger, go to the node tab, body entered. I'm going to call this AI enable door. Boom, connect that, and if you did correctly connect up your function, you will know because you have like this green arrow pointing into a rectangle or square here. And then body exited, AI disable door. Connect. And there we go for that. Oh, it looks like they oh, and there we go, they actually opened up a door and closed it right away. Oh, yeah, see that? They just opened up and closed the door. So yeah, the opening and closing of doors works just right, as you can see. The AI is very respectful as well. They know to close the door after opening it. Alrighty guys, so what I'm going to do now is I'm actually going to disable the enemy's visibility, and I'm going to go into the inspector tab here, and I'm also going to actually go into the process here. So you click on where it says process, and then with the process mode I'm going to change it to disabled. And the reason as to why I'm going to be disabling the enemy AI is because I want to enable it when we actually do interact, well, when we do actually find the safe down here. So once the player enters the trigger, which tells them basically, oh, you gotta find the password for the safe, that's when the enemy will then enable. Also, another thing I need to do as well is turn on the task UI. I just realized I've had that off the whole time. But yeah, so here's what we're going to do now. So what I'm going to do is I'm going to go into my script for the trigger. So with the task trigger here, what I'm going to do is I'm going to go get_tree dot current underscore scene dot get underscore node, and we're going to get the enemy, and then we're going to go process underscore mode equals, and then we're going to go process mode inherit. So what inherit does is that basically makes it so then the enemy process mode is equal to the parent object's process mode, which will be, you know, pausable, which means that when you pause and unpause the game, that will change the process mode of all the nodes from enabled to disabled. So that's why we're doing process mode inherit. And then we're just going to get this line again for the enemy, and then do dot visible equals true, so then we can make the enemy visible. And boom, there we go. So now the enemy will only function when we want it to, because of course we don't want the enemy to be enabled from the very start of the game. It's only from when we get down to here and then we actually see the safe for the first time when we then want the enemy to become enabled. So another thing which I'm going to do as well is I am going to implement chase functionality to this enemy. In the next part, what I'm going to do is I'm actually going to be making the model for the enemy, I think we'll be ready to make the model for the enemy in the next part, hopefully. But anyways, what we're going to do is I'm going to go add a child node to my enemy here, raycast. So raycasts are how we're going to be detecting the player. So I'm just going to rotate this by 90 degrees on the x-axis and it's facing forwards. And I think I'm going to put the raycast probably about here. And I'm going to stretch it out to about maybe -5. That might be a good distance. Maybe even -10 might be a better distance, something like that. And I'm just going to rename this to chase cast as well. You guys don't have to if you don't want to, but I think it's just going to be easier. And then I'm just going to duplicate that chase cast. And then with the target position on the x-axis, I'm actually going to change this to like 10. Or even maybe something like 5. Yeah, 5 might be better actually. So then what we have here is we have a second raycast which then points out this way. And the reason as to why we have a raycast which points directly forwards and then a raycast which points this way is so then the AI actually has more room to be able to detect things around it. And then we're also going to be doing a third chase cast as well, which instead of pointing 5 in the x-axis, it's going to be pointing -5. And there we go. And also, I think to top it off, I am going to do 2 more raycasts, because otherwise if the player's like standing right here, right, then the AI is not going to be able to detect them. So we're probably going to include 2 more raycasts. So I'm going to duplicate one of the chase casts, and with the x-axis I'm going to set it to -2.5. So basically now it's like a halfway point between 5 and 0. So 2.5 points out this way. And then chase cast number 5, which will point 2.5 out this way. So yeah. Alrighty, so what we're going to do now that we have our chase casts is we are going to save the scene, and then I'm going to go into my enemy AI script. Alright, so I'm going to start off by creating a new function. So we're going to go func, and I'm going to call this chase underscore player. And we're also going to be adding a variable to this as well, which will be a chase cast. And the type of this will be a raycast 3D. So what I'm going to do here is we're going to go if chasecast dot is colliding. So we're going to check if the raycast is colliding. Then we're going to go var hit equals chasecast dot get underscore collider dot name. I mean, no, we just do chasecast dot get underscore collider, I mean. And then if hit dot name equal to player, then what will happen is if not chasing, then chasing equals true. And then we'll also do destination equals player. So then the AI will then chase after the player because the player will become its destination. So what I'm going to do as well is in the pick destination function here, to make sure that the AI can't pick a new destination while it's chasing, we're going to make sure that it can only pick a destination whilst it's not chasing. So just a reminder that the exclamation mark out the front of a bool means not, so we're checking if chasing equals to false. But if you remove the exclamation mark, then you're checking if the bool equals to true. So exclamation mark out the front means if you're checking if it's false. No exclamation mark means if you're checking if it's true. Just a reminder there in case you've forgotten. So in my physics process function, what I'm doing now is I'm going to do chase underscore player, And then I'm going to enter in, and I'm going to repeat this function 5 times. And what I'm going to do is I'm going to input my chase casts, each one of my 5 chase casts into this function. So I'm going to be doing $chase cast, so then we can grab the first one and input that in there. There we go. Then I'm going to copy this function 4 more times, paste it underneath. And I'm going to go 2, 3, 4, 5, and there we go. So what I'm going to do as well is I'm actually going to create a new variable called chase timer, and this will equal to 0. And then so what we're going to do down here in the process function, we'll do if chasing ... and then go down a line, and then if chase underscore timer is less than, and then what this is going to be is this is going to be the amount of time we want the AI to chase the player for. So for this tutorial, I think I'm going to do maybe 15 seconds. So then what will happen is if chase timer is less than 15 seconds, we'll then be plussing onto the timer by 1 times delta, which means that this will basically just be a real-time timer. Otherwise, if chase timer isn't less than 15 seconds, so else, what will happen is then chase time will then equal back to 0, and chasing will equal to false. So then the AI is no longer chasing the player, and then we can actually pick a new destination for the AI. We are going to want to probably change the AI's speed as well. So what I'm going to do is underneath here in the process function where it says if chasing, we'll also do if speed not equal to, and then I think we'll probably do maybe something like maybe 5 for the chase speed. So if the speed isn't equal to 5, then speed will equal to 5. And then we'll just copy this, and then if not chasing in the process function, if speed isn't equal to 3, then speed is equal to 3. And boom, there we go. Hey everyone, so I've done quite a bit of stuff off camera, and I will explain why. So basically I was just thinking to myself, I wonder how I can get the stairs connected up properly to the rest of the nav mesh without it messing up everything else. So what I did was, so let me just go to my house scene to show you guys. So what I did was I moved the stairs out from being a child node of the first navigation region 3D. And what I did was I actually created a new parent node for the stairs, and that is a new navigation region 3D. So in case you didn't know, you don't just have to have one navigation region 3D in your scenes. You can have multiple. Like you might want to have a navigation region for the upstairs of a place, and then for the downstairs you might want to have a separate navigation region. And so what I decided to do was I decided to put the stairs onto their own navigation region. And now as you can see, everything connects up really well. So if you do have like a 2-story house, like with what I do, I have like a first story and then a basement. If you're doing a similar thing and you want to make sure that your stairs connect up properly to the rest of your navigation mesh, I do recommend making a separate nav mesh for your stairs, making them a child node of it. And then you can just, play around with your settings to get them right, and boom. So as you can see here with my second navigation region 3D settings, with the stairs here, I set the max climb to 5, and that's pretty much the only setting that I changed. Oh, and also I changed the cell height too, of course, to the exact same one we have on this nav mesh. But other than that, I have changed no other settings. I've only had to change 2 settings, and that was it. And also, if you're wondering what this pink is here, that means that it has successfully connected up to the other nav mesh. So if you do see a pink line between 2 of your nav meshes, that means that they are now connected up. So in order to connect up the nav mesh here, what I had to do was, as you can see, there's this invisible child mesh of my second navigation region, which is for the stairs. And so what I had to do was I had to create a new box mesh, and I had to put it between this nav mesh and the stairs nav mesh, so then I could bake the nav mesh again and then actually have them connect up, because they weren't connecting up properly. So I figured out that having just a placeholder nav mesh, just having a placeholder cube mesh here was good enough to be able to then bake them together. So yeah. And also you can then, just make that placeholder mesh invisible. I don't recommend getting rid of it, because otherwise that could, break your nav mesh if you try to break it again. So do be sure to keep it there, but you can keep it invisible. So yeah, that's pretty much what I've done off camera. Oh, and also I've added a couple new destinations downstairs as well for the AI to potentially go to. I will be placing a bit more now actually. So yeah, I can't think of anything else that I've forgotten to explain. I think that is all the stuff that I did off camera. The reason as to why I did all that off camera with the stairs navigation mesh and stuff is because I knew it was going to be very trial and error and I didn't want to muck you guys around. So yeah. Alrighty, so now we have 21 destinations in the house. And I don't know if we're going to need any more. I mean, 21 is pretty good. So what I'm going to do now is I'm going to find my enemy and I'm going to add on these new destinations. So 17, 18, 19, 21. Alrighty, and now we're all good. Hey guys, Omogonix back here. So I decided to do more changes off camera because I knew again there was going to be a bit of trial and error and I didn't want to muck you guys around, so I decided to do a bit of off camera work. And what I decided to do was I actually decided to separate the upper floor nav mesh and the bottom floor nav mesh. So now I have a third nav mesh in the scene. So as you can see here, I now have 3 nav meshes. So the first nav mesh is the top floor, second is the stairs, and the third is the bottom floor. So what I did was I basically just, unparented all the bottom floor nodes and I made them children of a new nav mesh, and then I, set my settings so the cell height is 0.05. But yeah, as you can see, the stairs are actually connected up with the bottom floor and the top floor as well now correctly. Earlier on it was just the top floor which is connected, but now the bottom floor is properly connected as well, as you can see by the pink line there. So that's how you know when your nav meshes are properly connected up. And also another important part to this as well is you need to make sure that, as you can see here, my AI's nodes, they're no longer in the middle of the grid here. They're actually on top now, sitting on like the floor of the grid. Also another thing that I need to mention as well, another change that I made is see this line here, how I had if not is on floor then velocity plus equals gravity times delta, which is meant to make the AI fall if it's not on ground. Well, I basically just commented this out because it won't even really be needed anymore. You can just get rid of this now if you want to, but yeah. Also, another thing I'm going to do before I test is I'm actually going to disable the locked variable on the trapdoor hinge. And the reason as to why is because for some dumb reason, I don't know why I ended up doing this, but for the key, I ended up adding some of the downstairs positions for it for some reason. I need to remove them later on. They're all named basically the same thing, so it's sort of hard to differentiate them, but yeah. And so yeah, so basically I'm just going to disable the trapdoor hinge for now, because otherwise there's a chance of the key spawning downstairs. And if that's the case, then well, guess what? I won't be able to get downstairs, and then I'll have to restart the game, and then there's another chance of it not being down, of it being downstairs again. But yeah. Also, I need to move this rug underneath navigation region 3D3, bake nav mesh. Should be more proper. And also, I'm going to bake the first nav mesh again to get rid of that carpet, and there we go. Alright guys, so another thing which I forgot to mention as well is, you know how I mentioned earlier how I used like an invisible mesh to connect up the 2 nav meshes here? Well, I also did the same thing with the stairs and the third nav mesh as well. I will show you guys. So basically, first off, I have 1 nav mesh here, and this basically divides, well, I don't know how to describe it, but it basically like helps separate the third nav mesh from the second nav mesh, so then we can actually create an edge here in which then we can actually connect up the stairs and the third nav mesh too. So this mesh here, if I was to move this out from underneath the third nav mesh, so it was no longer part of it, here's what would happen. So I'll go bake nav mesh, and as you can see, now the third nav mesh goes straight through the stairs, and there is no edge for the stairs nav mesh to connect to. But if it's a child of the third nav mesh, now as you can see, because it helps separate the stairs and the third nav mesh, it creates that edge. And also it's really tall as well, because earlier on I was just testing out the stairs to test out the nav mesh connections, and the agent kept on going inside of the stairs because of how the height of this mesh was. It wasn't tall enough. Also, I do have another little mini mesh down here for the bottom stairs as well, as you can see, which just helps connect up things, so yeah. Alright, so what I'm going to do is for the enemy, I'm now going to create a new function. So what I'm going to do is I'm going to do func stop underscore enemy. So what I'm going to do is I'm actually going to create a new variable. We're going to call this idle, and this will equal to false at the start. But when we do the stop enemy function, idle will equal to true. So basically, if idle isn't true, so if not idle, then that's when we'll do update target location and the rotation changing and stuff like that. So make sure you add end not idle into this section of the script here, just above your update target location and stuff like that. So now what I'm going to do is I'm actually going to go into my destination script, and we're going to do body.stop underscore enemy, because when the enemy goes into this trigger, then we can make that function happen on the enemy to make it go idle. And then what I want to do is when the AI selects a new position, what I want to do is I want to do idle equals false. So basically, when we're picking the new destination, idle will then equal to false. Also, something else which I forgot to say as well is in your stop enemy function, you should make it that the speed of the AI equals to 0. And in your pick destination function, make sure that the AI's speed sets back to the walking speed, which is free in this tutorial, or whatever you want it to be, of course. And also in your process function where you have if not chasing, if speed isn't equal to your walking speed, then set your speed to your walking speed. Make sure you add end not idle in there as well, so then it only sets the speed if your AI isn't idle. And yeah, so also something else which I did as well is I also added more placeholder meshes as well into the into this nav mesh here. So as you can see, I've added 2 temporary, well, they're not temporary, they're going to be here forever, but I called them temporary because, you know, they're only here for the nav mesh purposes, not for visual purposes. But these 2 meshes here are being used to make sure that the AI doesn't get stuck between the stairs and the floor when going up, because something which I noticed is that without these cubes here, when the AI tries coming up the stairs, sometimes it can get stuck in a loop of just like, you know, moving around here, and, you know, see how I'm rotating right now? That's sort of how like the AI would be when coming up the stairs. So what I did was I placed these meshes here and then baked the nav mesh again on the top floor, and now the AI, it doesn't get stuck between the corners of the stairs anymore. It actually just, you know, stays more proper now. So yeah. Alright guys, so I just want to give you all probably one last update on the nav mesh. I know there's been quite a lot. I've had to mess around with the nav meshes quite a bit. So anyways, what I did was I decided to change the agent radius of my stairs nav mesh to 1, just so then the agent is just more so going between the middle of the stairs, and there's less of a chance of it going to the sides of the stairs. It's just a way to make sure that the AI doesn't get stuck between the stairs and any ledges when they're going up, since that was happening earlier. I also changed the agent radius down here to 1. Remember, you don't have to have the exact same settings I'm using for my nav meshes. You can use whatever settings you want for your nav mesh, just whatever works right for you. Then yeah. One thing which I forgot to do is I forgot to make it so then when the AI enters the door trigger, we need to make sure that the door isn't already opened, because one thing I found, right, is if the AI opened and closed the door, if I then opened it afterwards and then the AI enters the trigger again, the door, it just snaps back to the close animation, then opens again, and it just doesn't look right. So what I'm going to do here is we're going to make sure that the door isn't opened when the AI enters the trigger. And then for the disable door function, we're going to make sure that the door is opened before it then closes again. So then it doesn't, you know, break immersion or anything like that. But also with your avoidance on your navigation agent 3D, make sure you turn that on. So by default, avoidance is off, but make sure you turn it on. And also I've got my radius set to 1 here. As you can see, I've changed it to 1. The default is 0.5. You don't have to do that if you don't want to. That's just what I'm doing to make sure the avoidance is, you know, more accurate. Also, with the player, I actually gave them the collision layer and mask 2 now. So not only did I have layer and mask 1, but they also have layer and mask 2. And the reason as to why is because there are certain objects that we don't want the AI to actually collide with. But anyway, so with the collision layer and mask, make sure you have your players set to 1 and 2. Also change your players' raycast collision mask to 1 and 2 as well. So usually it was just 1, but now I have 2 set for it as well. And the reason as to why is because we don't want the AI to be colliding with the door. So what I've done here is I've disabled collision layer and mask 1 on the door, and so now that's set to 2 on both, and so that means that the player's raycast can still collide with the door. And also with the trapdoor as well, I disabled collision layer and mask 1 on this and set it to 2, so then only the player can interact with it, since I don't want the AI to be stopped. Now you might be thinking to yourself, but oh wait, what if the player tries to keep out the AI and, then they can just see that the AI can walk straight through the trapdoor? Well, I'll work that out later on, of course. But anyways, alright, so now we've got to get back to the code here. So as you can see, these 2 commented out lines were the old lines I had. They're currently what you would most likely have in your script for what I used for the velocity and the movement. But what I've done now is I've commented these out, because instead what you want to do is you want to set this. And the reason as to why I'm now doing this differently is because usually when I use the AI avoidance in Godot, I always thought that it was mainly for like avoiding other AIs, so the AIs didn't get too bunched up together. But I think that it might be also useful for just, general velocity. So yeah, instead of these 2 lines here, you just want to instead do navigation agent 3D.set velocity new velocity. It's basically just a better way of setting the velocity for the AI. The reason as to why I was doing things differently here is because I didn't really think that I'd have to worry about the avoidance, but I just want to be extra safe for this tutorial. And then also I have a new function down here called func compute velocity. So basically we just compute the safe velocity. And as you can see, the lines that were originally up here have now been moved down to here in the compute velocity function. And then what I did was I went to my navigation agent 3D, and then when you go to the node tab, you'll see your signals here. You then want to just connect up this compute velocity function that you've now got into your velocity computed signal. And so I think those there are all the last changes that I can remember. Hopefully there's nothing that I've forgotten there. Sorry that there's been a bunch of off-camera stuff in this tutorial. It's just that I've been wanting to make sure that, everything that I'm doing is correct and stuff. Because when it comes to AIs in Godot, it all depends on the project you're making. You might have to adjust the AIs differently depending on what you're doing. If you do decide to use collision on your AI, make sure that there is no spots in which your AI can actually get stuck. Like for example, before the AI, he for some reason got stuck on this corner of the stairs here. The AI doesn't really need to have collision with stairs, so what I'm going to do is I'm just going to go into here, and I'm just going to switch over the stairs collision layer and mask to 2, since the player can still collide with it, but the AI can't. And this is just going to stop these corner of the stairs from stopping the AI from being able to go where it wants to go to. Alrighty, so here we have the AI just walking around. Well, he's idle at the moment, just in a position, but he'll get walking again in a moment. There he goes. So at the moment I'm just following him to make sure that, there's nothing that he's getting stuck on or anything like that, because obviously you don't want your AI just randomly getting stuck onto things. That can be annoying. Alright guys, so I think that's pretty much going to be the end of today's video. Of course I will show the AI chasing just in a bit, but I do want to sort of just do my outro here. So thank you all for watching once again, and if you did enjoy, be sure to like, comment and subscribe for more. Hopefully you guys were able to get your AI working well with the, all the tips and stuff I gave in this tutorial. I know I don't know how long this tutorial is going to be, but I've recorded a lot of footage for this tutorial, probably more than any of my other tutorials. I don't know how much of it's going to make in, because a lot of it is mistakes and stuff like that as well. But yeah, there's been a lot of stuff recorded for this. Hopefully, you know, I'm able to edit it down into a digestible form for you guys to be able to easily learn, and so then it's not confusing and stuff, because that's the last thing I want, is for my tutorials to be confusing for you guys. But yeah, thank you all once again for watching. And without further ado, in order to end off this tutorial, how about now I actually go enable the chase cast on the AI, and we see how it chases. So I'm just going to go press enabled, and now let's go start and see how the AI chases us. Alright, so there's the AI, now let's make him chase us. You coming? Oh no, the AI just ignored me. He's just like, nah, sorry, I want to go over here. How about now? Alright, so the AI has decided to chase after me now. As you can see, he is now chasing me. So there was a bit of a glitch there where when he was idle, he didn't want to chase me. I'll have to fix it up in the next tutorial. Don't really have any more time right now. I've done so much recording for this already. Here he comes. So yeah, here's the AI in chase. He's currently slow right now because that's how I have him set. But don't worry, I will change that later on. But yeah, so as you can see, he can chase pretty well. Now he's just decided to stop chasing me and he wants to go to another destination. Oh well. Come on AI, let's go. I want to try, you know, make sure he can get around, you know what I mean? That's why I'm making him get into a chase with me right now. Trying to test him out. Test out his navigation skills. Oh, he's still coming. Alright, so yeah, it looks like he's going pretty well. He's not getting stuck on anything. He's doing really, really well.